In this question, Juan is skiing down the hill at a 25-degree angle. Okay. Juan is 70 kilograms, and the coefficient of friction between his skis and the snow, that's this letter, is 0.1. Okay. What is his acceleration down the hill? Alright, so we look at this problem, and there's forces acting on Juan. So what are the forces? Here's our free body diagram. We've got gravity acts straight down. The normal force is perpendicular or at right angles to the surface. And our last force is the friction that's slowing him down. Now, for this type of problem, it's always easiest to make our coordinate system, which is our x and y directions, in the same direction as the acceleration. So Juan is accelerating in this direction down the hill. So let's make our coordinate system y and x so that our x is in the same direction as the acceleration. We'll see when this is useful in a couple steps from now. So now we want to look at all of our forces. Normal force, friction, and gravity, and decide if they're in the x or y direction. And if they're not, we've got to split them up so that they are in the x and y direction. So it looks like Fn is in the same direction as y. Looks like force of friction would be in the negative x direction. But our gravity here, our gravity's got a little bit in the y direction and has a little bit in the x direction. So we've got to split that up into the x and y components. Okay, so we proved this in class, but I'll try to show it again just for a reminder. We want to know what this angle is here, and how does that angle relate to 25 degrees. So let's look at this diagram. Just redrawn our free body diagram with the slope. So we've got, this is our angle, which in our case is 25 degrees. Okay. So we can make some right angled triangles, and this will help us figure out what this angle is right here. So here's one right angled triangle. Okay. So if this is 90 degrees, then this symbol, alpha, plus, we'll give a different symbol for this, we'll call it x, plus x, that needs to be 90 degrees. I know that because the triangle has to add up to 180 degrees. So x, which is this angle right here, plus alpha is equal to 90 degrees. Alright, now we can make another right angle triangle. I drew it in right here. If that's a right angle, then x plus something has also got to be equal to 90 degrees. If I'm looking at this, where this is my question mark, which would be this angle right here. Now looking at these two statements, you might be able to see that these two must be the same number, right? If x plus alpha is 90, question mark plus x is 90, question mark and alpha must be the same thing. So in our diagram, if this is 25 degrees, that means this must also be 25 degrees. So I'll just draw an arrow in here. 25 degrees. Alright, now we can take our free body diagram and split it up into the x and y directions. Try to do that yourself right now. Alright, so the only vector, or force, that needs to be split up into the x and y direction is force or gravity. So if this is force or gravity, let's find out what these two sides are. I'm going to call this my y, it's in the y direction, my x, because it's in the x direction. So cos theta, alright, Cos theta is adjacent over hypotenuse. So let's sub in our values. Cos 25 degrees, my adjacent side is y. My hypotenuse is the force of gravity. Let's just isolate for y. Now we can do the same thing with in the x direction. Sine is opposite over hypotenuse. To find this result. Go through the same process, but instead of using cos, use sine. Alright. So now it looks like we have this x, we have this y. So it looks like all of our forces or vectors are split up in the x and y direction. So just like we've done with all vectors, let's make an x and y table of our forces. And our x, we'll start with force of friction. We have negative force of friction. Our coordinate system says x is in the positive direction down to the right. So force of friction is back, so it's negative. And it's only in the x direction. Our normal force is only in our y direction, our positive y direction. So I have 0 Fn. And our force of gravity, we found it's got both an x and y part. So we need to figure out which one's negative, which one's positive. So y is down. So we've got negative, here's our y, Fg cos 25 degrees. And in our x direction, we found to be this. Now our x direction is in the same direction as our coordinate system, so we're going to say that's positive. Fg sine 25 degrees. It's this component of the gravity that actually accelerates the skier down the hill. Those are our three forces. So we can say the net force in the x direction is the mass times acceleration in the x direction. We're looking for acceleration, so let's try to find it here. Fg sine 25 degrees. I'm going to put this one first because it's positive. You could have put negative force of friction first if you'd like. These are all the forces if we add them up in the x direction. That's our mass times our acceleration in their x direction. This is what we're looking for, the acceleration. So let's see if we can solve it right now. Force of gravity, the definition of force of gravity is equal to mass times the gravity. You can put that somewhere on the side. And the force of friction is the coefficient of friction times the normal force. So let's sub in these two into this equation and it'll help us solve. Fg is mg, mass times gravity. Our sine theta doesn't change, sine 25 degrees, minus force of friction, coefficient of friction, which we know, times the normal force, which we don't know, is equal to mass times acceleration in the x direction. So we can start plugging in our numbers. We know the mass, we know g is 9.8. We've got sine 25 degrees here. The coefficient of friction is 0.1, so we can put that in. But then we get to the normal force and we're stuck. We have no numbers for the normal force. We don't know what that is right now. Mass, again, we're trying to find the acceleration. So we need to find what this normal force is. And if we're stuck in the x direction, we can look in the y direction and it'll help us figure out what that normal force is. Alright, so let's look in the y direction for a normal force. The net force in the y direction is the mass times the acceleration in the y direction. So all of our forces in the y direction, we've got Fn minus Fg cos 25. So that's just these two added together. Now, you can see why we made our coordinate system in this way. Our skier, if we say the positive x direction is down the slope to the right, our acceleration is only in the x direction. The skier isn't accelerating in the y direction, as we define the y direction being in this direction. He's only accelerating in the x direction. So his acceleration in the y direction with this coordinate system is 0. If we made the coordinate system like this, he'd be moving a little bit in the x direction and a little bit in the negative y direction. So that makes the problem a lot more difficult. So whenever you can, generally, whenever you can create your coordinate system in the same direction as the acceleration, it's always very helpful. Because with this question, because of our coordinate system that we created, the acceleration in the y direction is 0. So 0 times the mass is 0. So this makes it a lot easier. We can just solve for the normal force now. We sub in. If you remember, the force of gravity is mass times gravity, cos 25 degrees. We have this. We have what the mass is. We have what gravity is. So we can just sub in those numbers: 70 kilograms. 70 kilograms times 9.8 meters per second squared times cos 25 degrees. Again, it's positive 9.8 rather than negative 9.8 because our negative is shown up here. We put our negative when we were drawing the direction of the force of gravity. Notice it was down, negative Fg. Put that in the calculator, you find it 621.7. So now what we're going to do is we're going to take that number and we're going to sub it back into this equation. Remember, we were trying to find the normal force so that we can solve this equation for the acceleration. So mg, let's go back and find what we wrote. Mg sine 25 minus mu 621.7, that's what we found here, is equal to mass times the acceleration in the x direction. Let's sub in our numbers. Check to see if this is what you got for when you subbed in your numbers. And now we're going to solve for a. So this is 70 times a, so to get rid of that 70 we have to divide both sides by 70. You should get 3.25 meters per second squared. So let's quickly review what we've done. You want to draw your coordinate system in the direction of the acceleration. That's the key. Because when you do that, you break up all your forces into the x and y direction. We write our F net is equal to MA statements. You'll notice that one of them is going to give you an acceleration is equal to 0.